would please make sure your name is on this. Today is 10/28/22, and I only have 1 hour in science, but all right, are you ready? Our voices are off, we're paying attention. 8 newtons of upward force. How would we show that? Any guesses? What do you think, Evan?
Building.
You think? Well, we could, yep, we could definitely start like on the bottom and fill in up. I'm kind of thinking we're gonna draw some lines. Is that okay? So if we start at a point, any point, pick a point. And we know we're going upward, which is why I picked a point kind of on the bottom. How many boxes do you think I should go up? 8. So 1, 2, 3, 4, 5, 6, 7, 8. And to show that it's going in this direction, I'm going to show the arrow. Is that fair? Does that make sense? So we went 8 boxes up. So if number 2 says we're going 3 newtons of force to the left, we should probably start on the right. Is that fair? It doesn't really matter where we start our force, but how many do we want to go left? 3. So I'm going to go 1, 2, 3, and we're going to show that it is going to the left with our arrow. So this was 3 boxes left. Does that make sense?
Put in the wrong one. No.
12 newtons of downward force. So instead of starting down here like I did to go up, I'm going to start up here since I'm going down. And I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. 12 down. So this was 12 boxes down. All right, try 4 through 6 real quickly. Make sure you're understanding how you can show these. Hopefully, they look something like this. Start somewhere and go down. 1, 2, 3, 4, 5, 6. 11 to the left. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my arrow is at that last count, right?
Mm-hmm.
And then 13 upward. So make sure you're starting somewhere and going up. 1, 2, 3, 4, 5, 6, 7, 8.
Did you make number 5 to the
10,
right?
11, 12, 13.
Did you do that, man?
Oh my gosh, yes, I did. So guess how I could easily fix this?
Put the arrow on the other side.
You got it. Make sure your arrow is going to the left. Oh dear, what did I do? I just clicked on something. There we go. So I had to change. I put my arrow here, but that was pointing right, and this is to the left. So I switched and put my starting point here and put my arrow on the other side. Hey, that's a great way to fix it, right? Okay, now I want you to think about these as the sum of forces. Well, it's going to get a little bit trickier. If they're going in the same direction, it would be easy to say this like 1, 2, 3, 4 plus how many down? So 4 newtons down and another 8 newtons down would also be 12. Does that make sense? Alex, do you need to go, or Andrew, do you need to go? Because this is not okay behavior for 8th graders. So this is 4 newtons down plus 8 newtons down would give us this 12 newtons down. We also learned that sometimes we had opposite forces reacting. So how could I get 6 if I had two things going in opposite directions? What do you think, Andrew? What could I do?
Angle?
No, not at an angle. I want them to go opposite directions. So
Oh.
what would be the opposite of going down?
Up.
Going up. So how could I get 6 if another force was applied on it going up? Yes, Kai, what do you think?
That from force is 6 newtons higher than the other one.
Good. So 6 down has to be 6 newtons stronger going down. So if I told you there were 3 newtons going up, how many more would we need to go down? Excellent. So we could have 9 newtons going down plus 3 newtons going up. Does that make sense? This is kind of like integers in math, right? When they're different, we have to subtract them, right? Isn't 9 minus 3, 6? And whichever our bigger number is, our resulting vector is going in that direction. Right, Savannah? Please stay focused, guys. Gets a little bit trickier. So what's another way, either with combining them that are going in the same direction or combining them going in different directions, that I could write 11 newtons of force to the left? You can keep it as easy or make it as difficult as you like. What do you think? What two vectors or forces could we add to get 11 newtons to the left? I know I'm making you use your brain, Isaac. Thanks for volunteering to do this one for us. What could we do? 1 plus what?
What? No.
I'm looking at number 5, honey. We're trying to get 11 newtons to the left. Well, go with what I was giving you. 1 newton left plus what? One newton left plus how many more newtons do you need to go left to get 11 newtons to the left? 10, right? So I could say 1 newton left plus 10 newtons left gives me 11 newtons to the left. Okay, so what if I gave you 5 newtons down? What would I have to add to 5 newtons down to get 13 units up? Give everybody else a minute, Kyle. Try and figure this out. What would I have to add to get that? What do you think, Elena? So 15 would give me, well, 13 would give me 8 newtons upward, but I want 13 total. But you're right, if I took 5 newtons down and added it to this 13, I would have 8 newtons upward. So how do I get it as a resultant vector of 13? 5 newtons down plus 68.
No.
What do you think, Savannah? So 5 newtons down. So if I want an upward force, and I just gave you a downward force. So if both of these were upward, I could say 5 newtons up plus 8 newtons up, but I just gave you 5 newtons down. All right, Isaac, here's your redeemer. 18, excellent. So 18 newtons up. So do you see if I went down, I'm sorry, up 18, but then back down 5? So if I went up 18, you could count all the way up to 18. This is 13, 14, 15, 16, 17, 18, and back down 5. 1, 2, 3, 4, 5. Your resultant vector is 13 newtons. It's a little bit tricky. Remember, though, if they're going in the opposite direction, you're finding the difference. Just like when your signs are different with integers, you find the difference and subtract them. So I would take 18 minus 5, isn't that 13? And the direction it goes is equal to the bigger one. My bigger one was going up, so it's an upward force. That was a lot. Are you ready? Somebody's hollering up there. All right, write out the amount of force and direction for each of the vectors you are given in each grid. Are you ready? So how about 8 newtons up plus 2 newtons up? So I would either put your answer here and draw it, or draw it and then label your answer. So what I mean by labeling my answer, if I was on the front, I would write 8 newtons right here, or 3 newtons right here. So make sure you're either labeling it on your grid or showing somewhere where you are setting it equal to something. And then I want you to do 6 newtons left plus 2 newtons right. So what is your resultant vector? Give those a go. If you're getting stuck, you can draw these out and see what would happen, right? So if I was drawing this one, I might start by going 8 up. 1, 2, 3, 4, 5, 6, 7, 8. And then you could start right at that point and go up 1, 2. So the resultant vector, if I added these two together, might look like this from here all the way up to here. And then you could count if you needed to. Or you might have 6 going left. 1, 2, 3, 4, 5, 6. And then you can go back 1, 2 in this direction. And where do you end up? 1, 2, 3, 4. So this would be 4 newtons. And which direction is it going in? What's the direction of your bigger number?
Left.
Left. So 4 newtons left. We didn't answer that this one was up. Sorry. So you can draw them out to figure them out. You can do the math to figure them out and just draw the resultant vector. Find a way that works well for you, okay? Finish these last 4 real quick. Ooh, what was your resultant force or your resultant vector for number 3? What did you say? What was number 3? What'd you guys say?
For 3,
Yeah.
would be the resulted, it would be, it would be over 9. Is it right? Would be 7. Or wait, no, 7. sorry. I was thinking.
7.
Right.
7 newtons to the right. So make sure you either you say 7N and draw an arrow or write out the word right. How about number 4? What'd you get, Isaac? 11 newtons down. Very good. Make sure you're showing the vector as well. What did you guys get for number 5, Andrew?
0 up, 0.
0. So just 0 newtons, right? 0 newtons. If it would not have a direction if it wasn't going anywhere, right? It's just standing. All right, last one, number 6. What'd you guys get? Tell me.
Oh, 1 left.
1 Newton left. All right, and hopefully you showed that. And your arrows were going in the proper direction, right? Right, down, nowhere, and left. Okay, looking here, I want you to draw a pair of combined forces and the resultant that fits the descriptions you are given. So you're going to show your work off to the side of the grid, and then here's where you're going to show it. If you want to show it like on one part of the grid and show your resultant there, if that's easier, that's totally fine with me. 2 friends, Norman and Skunky, are pulling together on a heavy box of leftover meatloaf to move it to a leftover meatloaf storage warehouse in the bad part of town. One friend uses 4 newtons of force and the other uses 6 newtons of force. So if they're pulling together, they're going in the same direction or opposite direction? The same direction if they're pulling together. So show that. In part C, that should be a pretty quick one. 4 and 6, and they're going in the same direction. So combined, they should be a total of how many newtons in that direction? 10. Yep, good. So show a vector of 10 newtons. It can be going in any direction. It's going towards the storage warehouse. So if you wanted to draw a storage warehouse on there, whatever direction that is, it doesn't
The
matter.
warehouse is to my left.
It's to your left.
I
That's
already
fine.
did that.
Does that make sense? Are we following along? Okay. All right, so now, we've got 2 sworn enemies. Olivia and Karen the Destroyer are fighting over the last Cheeto in the bag. One person pulls with 7 newtons of force in their direction, while the other pulls back, so in the opposite direction, with 8 newtons of force. How would you show this? And what would be their resultant force? What's their resultant vector? 1, right? So show 1 going in one of the directions. That's not so bad. These are okay, right? Is it making sense? A little bit? Just a little bit. Just a little bit. Alright, here's your turn.
Oh.
You get to write your own vector word problems. You don't have to get too complicated. Just keep them simple. And then draw out the problem and resultant on the grid.
2 newtons left. Wait, was that the other one?
I don't know, are they pushing and pulling on the same object?
Oh, they have to be going.
Remember, they're either applying force on the same object. Yeah, they need to be applying force on the same object if we're adding them up, right?
Oh, this would be hard.
All right, so I'm gonna give you a couple minutes, and when you get that done, if you will just turn that in.
Wait, your name